In the previous section, we transferred buffered data using FPGA FIFOs. By the end of this module, you will be able to handle FPGA FIFO overflow and underflow conditions and describe the behavior of an FPGA FIFO. Okay, so now let's talk about FIFO overflow and underflow. We kind of mentioned it in the previous module. Let's talk about it a little bit more now. So an overflow condition, this happens when the writing loop executes faster than the reading loop. So what would happen is when you're trying to do a write to that FIFO, the FIFO is already filled up and the FIFO write method will time out. So when this happens, data is not written to the FIFO until there's space available. Okay, and the only way that you can have space free up in a FIFO that's full is one, you can read an element out of that FIFO, which creates space for another one to put in, or you can reset that FIFO. So if the FIFO remains full and you keep trying to write to it, at that point, you're losing that data that's happening. So because you're losing data, that's why it's important to know when you're overflowing. Now let's talk about underflow. So underflow happens when the write loop is executing slower than the read loop. So in other words, the read loop is executing faster, and then at that point, the FIFO read will try to read from the FIFO, but there's no elements there to read yet. Okay, so the FIFO is empty, and then when the FIFO read tries to read from it and it times out, then that would indicate a underflow. So how would you handle FIFO overflow or underflow? So the method for handling this would depend on the importance of lossless transfer. So if you do care about making sure that every piece of data is transferred from the writer to the reader, then you would want to monitor the overflow. So let's take a look at this block diagram. Okay, so we have a FPGA I/O node, and then we're using that value and we're going to write that value into our FIFO. So if we take a look at our write method, we're writing that element to the FIFO, and then we have a timeout of 0. So what that means is when it gets to this write method, it's going to check and see if the FIFO is full. And if the FIFO is full, because the timeout is 0, it's not going to wait at all. It's just going to immediately time out. Okay, and timed out will equal true. So let's say the FIFO is not full yet. Okay, and we're running this loop, and we keep writing. Well, if the FIFO still has space, then we're still good to go, okay? And everything is operating as normal. However, if the FIFO fills up, and then we try to write to it with this write method, then it's going to time out, right? Because if the FIFO is full, we can't write, there's no space for us to write a new element into the FIFO. At that point, timed out is going to output a true value. So overflow, that indicator will now be true. And at the same time, we see that it branches down and it also stops the loop. So as soon as that overflow condition occurs in this particular VI, we can be alerted that there's an overflow that occurred, and we're also stopping the VI because we know that we're getting some data loss and we need to go fix something, okay? And the data has been compromised. So another way that you can handle this is if you wanted that while loop to keep running, for instance, instead of stopping the loop, what you could do is you could look at the timed out output, and you can latch it using either a shift register, or you can use a feedback node. And you can just have something that tells you if the loop ever had a overflow condition. Okay, so in this next portion, we're going to do a demonstration, and we're going to take a look at how FIFO works with writing and reading, and how many elements are in the FIFO, and we'll take a look at overflow and underflow as well. Okay, so let's take a look at this demo. So if you want to follow along or play with this later, you can find the same VI in the exercises folder in the demonstrations folder. So let's take a look at this VI. I'm going to go ahead and run this. And let me talk about a couple things. If I hit write, we're going to start writing to our FIFO. And if I hit read, we're going to start reading from the FIFO. Okay? So this bucket that we see here, we have a FIFO, and the size of that FIFO is going to be 36 elements. Okay? So this bucket here is going to show us how many elements are currently being used in the FIFO. Okay? So let's go ahead and hit write. Notice that I'm writing, and because I'm not reading, the FIFO is starting to fill up. Now if I was to read, notice that I'm writing and reading at the same rate for this particular example. And because that's happening, the FIFO is just remaining at 25. Okay? Now if I stopped writing and I kept reading, what do you think would happen? Well, let's see. If I stop writing, but I keep reading, then I should start emptying the FIFO, right? So let's see what happens if I keep reading. So notice that the Fifo Underflow is turning on right now. The reason why is because I'm trying to read, but there's nothing to read in the FIFO. Okay? So underflow conditions usually aren't that bad. I mean, if you're trying to read and there's nothing in the FIFO, and it underflows, then that's not too much of a problem. You just keep trying to read again until something appears in the FIFO. Okay? So I'm going to stop that, and I'm going to start writing again. So let's see what happens if I keep writing and the FIFO fills up and I still keep on writing. So notice it's starting to get full. Now my write method, now I'm trying to write, so I'm trying to write some new data, but I can't write anything because the FIFO is already full. It's already been filled up to its size of 36 elements. Okay? So notice that on the write method, if I time out on that, then the timeout is going to equal true, and that's going to indicate a Fifo overflow. Okay? So a Fifo overflow is going to be bad, because a Fifo overflow means I'm trying to write some data right now, but it's being lost because I don't have any room in the Fifo to store it. So hopefully now you have a better understanding of how writes and reads affect the Fifo, and what a Fifo overflow represents, and what a Fifo underflow represents.